Hello guys, let's solve another Leetcode problem. Remove nth node from end of list. We are solving blind 75 Leetcode questions. We are in the linked list section and we are doing this remove nth node from end of list. So it's a medium difficulty problem. So given the head of a linked list, remove the nth node from the end of this list and returns its head, right? So we are given a linked list 1, 2, 3, 4, 5. This is one of the input. Another input we are given actually n equal 2, right? So what we're going to do, we want to remove the nth node. So, the last node, the 5, that's start with 1 index. So this is your first node and this is your second node. So basically the red node, we want to remove from the linked list. Basically, we'll return the same thing, same linked list, but 4 is gone. Basically, 3 will point to the 5, right? And if you can take a look at the other two examples, right? Actually, the head is 1 if you have one node and you want to delete one node. So you basically return an empty list. And if you have 1 and 2, you want to return the first element. So basically, you remove the second node, right? There are multiple ways to do it. The brute force method, I would say, just keep track of all the elements what you have already seen. Only problem is that, for example, if you have a stack, you can actually push all the nodes, right? So 1, 2, 3, 4, and 5. Then you pop back. When you pop 5, that means you're already done 1. And then you pop 4 again. So that means 4 needs to be removed, right? So you store the 5 somewhere in a temporary variable. And then you pop one more element like 3. And for the 3, what you want to do actually, 3.next would be the temporary variable what you stored here, right? The runtime complexity will be order of n, but you need actually extra storage to store all these things into the stack data structure, which will be order n, right? That's one way to do it. If you want to do it a little bit efficient way without order in storage, then you can use two-pointer approach. And for the two-pointer, what we will do, we have a slow pointer and fast pointer. And let's draw these one and then let's see how we want to do it. So we have 1, 2, 3, 4, 5. So your first pointer would be the first location, right? And then you can have another slow pointer. So to make it a little bit easier for the S cases, we will actually add in one extra dummy node here. So these will be your dummy node with 0. And then this is your extra node. Just keep in mind this one, right? So this is the node you added, but basically this was the final result. What we want to do, so you need actually two elements. So you want to apart those two values, slow and fast, to two location, right? So basically you increase the fast pointer once and twice. So your fast pointer would be here because you have n equal 2, right? And your f is pointing 3, and then your s is pointing the first location. Now, what you want to do, so you see actually your slow and fast pointer, those two elements are actually the nth node apart, right? So now you go to the fast, increase the fast pointer one at a time. As soon as you hit, so you reach it here. When you reach here, the S will come to here. And then F reach 5 fast and then slow reach here, right? And now F reach here, which is a null pointer, and S reach here. So you see again, your S and F are nth node apart. So now we basically want to do, you actually remove this 4. So basically slow.next, you basically want to point this the next value here. So that's how the algorithm works. So let's go ahead and implement it. So you need a new node. So we'll call it a dummy node. And dummy node, you can just define a list node with 0 value, and then the next pointer is head. So it's basically pointing to the head pointer. So you have 2 pointers, slow and fast. Slow is pointing to the dummy, and then fast is pointing to the head. And while your n is there, you basically want to forward your fast pointer one at a time, and then decrease the end pointer. So what will happen actually after this while loop, your fast point to 3 location. Now you want to update your fast as soon as the fast doesn't become none. You can update the fast pointer one at a time. Same as slow. And when you are outside of this, you want to update your slow next pointer with the next value. So basically you want to do slow.next. And finally, you want to return dummy. So your dummy is still pointing to the 0 location. So, but you want to return the head. So that will be your previous S pointer. So dummy was here, but so finally we return this one. And that should be it. So run this one and submit it. And let's talk about the runtime complexity and space complexity for this problem. So it beat 100% of this other runtime complexity. So let's talk about the complexity. So for space complexity, we are keeping track of, we added 1 extra node, so which will be order of 1. And then we added slow and fast. So basically we added 3 total extra variables, so which is a constant. We are going through these while loop once. So basically this is n can be the maximum, can be the least of the node, right? So this will run order n time. And then from that node, you are going from at the end, right? So you are going through. So for the fastest step, you are going from left to right, from left to right. And then for the next one, you are actually going from left to right. So maximum, it will be, this while loop can be maximum order n. These while also order n. So overall runtime complexity will be order n, and space complexity, we are not storing anything except those 3 constants, so 3 variables. So this will be order of n. But if you use the stack approach, if you store all the nodes in a stack, then you will need order n. So that's not efficient, but this is an efficient implementation. Yeah, thanks for watching. I will see you in the next video.